we're going to work with radicals more, simplifying. So we've done it before. I'll review what we've done before. We're going to take it a step further. And then we have 6.6, which off the top of my head, I can't remember what it is. And then our test will be next Wednesday. So we'll review Monday, Tuesday of next week. Next test is next Wednesday, okay? Albert I.O. has been up since last Friday. You have until next Monday to get it done, okay? I think there's 9 questions. It's 10 or whatever homework points, whatever I put in. And that is due next Monday. It's due Monday. Yep, it's brand new. It's the one I put in last Friday. So if you already did one in the last few days, it's the same one. I just had it open for a really long time. Okay, is that what you meant, Olga? Yeah. Okay. So I want to remind you how we simplify radicals. On that last test, that was the part of the test most of you did the best on. Like that last test was pretty hard with like the inverse stuff and the graphing. That was challenging. But when it got to this stuff, most of you got all your points for that. And this is a reminder of what that was. So as a reminder, we said, okay, the square root of 4 is 2. And because this is a 2 right here, right? When you don't see a number, you know it's a 2. You don't have to guess. You don't have to wonder. It means 2. We divided our exponent by that number. So 4 divided by 2 was 2, and 6 divided by 2 was 3. And sometimes we did even, odd. Don't worry about that right now. But that was our final answer. Okay? We sometimes did cube roots. We even did fourth roots. Cube roots. The cube root of 8 is what?
2.
2. 3 goes into 12 4 times. And 3 goes into 3.
That's 1.
Just y. 1 time. Can you write the 1 right there if you want to? Mm-hmm. Not wrong to do that, but you won't see it. So that's what we did in the past. We're going to do the same thing, but with harder problems, okay? So what I think is the best thing for you guys to do when you start these problems, like pretend you're taking the test or whatever, I mean, you're going to have the notes in front of you for this, is to make a list, if you want to, not a requirement, of the square roots, the cube roots, and the fourth roots. Why? Because it makes what we're about to do so much easier. Even if you're pretty good with, like, especially the square roots, you probably have those memorized. 1, 4, 9. It's actually helpful, even if you're good at this stuff, to have the list in front of you. So let me do this. I can't talk and do it at the same time, so let me write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on from there. So the square root list is always a little bit longer because there's more of them. You're only doing it with 2's. The cube roots, 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. These are pretty much the only ones you ever see. Can it go higher? Yes, but those are the pretty common ones. And fourth roots, we don't go very far with those at all. 1 times 1 times 1, 2 times 2 times 2. I don't even know what the 3 is. 3 times 3 times 3 times 3, 4 of them, is 81. So we get to 81 really quickly. Okay, so, and that keeps going on and on. So I would make sure you have these somewhere that you can go back and look at them. You know, like tomorrow we're going to do more of these. Instead of writing this again, just know where this is in your notes so you have it. And you can easily create this yourself. You're sitting at home, you left your notebook at home, but you want to do it. Of course, you could go on Canvas, but it's just multiplication. So 1 times 1, 2 times 2, 3 times 3. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. 1 times 1 times 1 times 1, 2 times 2 times 2 times 2. It's that many numbers of the same name. Okay? All right, so how is that going to help us? Let's look ahead at what we have. We have square root, right? So we're looking at our first root. And just starting with the number, it's 75. 75 is not in our list, but that doesn't mean we can't simplify it. And we've done this before. Think about what the square root of 75 is, or what number goes into 75 that's in that list that's a perfect square. What number goes into 75 that's in that list? What? 25. Yes. So 75 is 25 times 3. Okay, so we're done with 75. We've now broken it down to this. And I would use the way I do the notation here. It's going to be very helpful, trust me. 25 is a perfect square, right? The square root of 25 is 5. I'm going to put it on top to save for later. I'm protecting it. I'm putting it somewhere safe. Does the 3 have a perfect square? Can we do the square root of 3? The answer is no. I'm going to circle it, and I'll explain to you in a second why we do it like that. Okay? Now we do our variables one by one. We'll start with x. We do 12 divided by what? Divide by 2. That is 6. I'm going to put it up here for safekeeping, because this is going to be my answer. Everything I put up here in a minute, I'm going to write as my final answer in the front of the radical. Anything I circle is stuck underneath the radical. It doesn't get to come out. Okay? That 3 is one of those numbers, right? All of this stuff I'm writing down here is still under the radical. I'm just using it as like a workspace. Here, look. How many times does 2 go into 7? 3 times evenly, right? Goes in 3 times evenly, because 2 times 3 is 6. How many y's are left over? 1. That gets circled. Let me explain to you what I mean. I did 2 goes into 7. That's what I just did. 2 goes into 7. It goes in 3 times with a remainder of 1. Okay? So 3, there were full 3 sets of y. That comes out. That remainder is left underneath. And now I'm ready to write my answer. And if you use my notation, this step is brainless, really. I take whatever's on top and I write it all together. 5x to the 6th, y to the 2nd. That's this, this, and this taken care of. Then I have leftovers of 3 and y underneath. So what's different from this a and this a, between these two, is when we did these before, in these examples here, there was no radical left. Everything was a perfect square underneath, or a perfect cube. In these, we are simplifying. We have to take out what's allowed to come out. Whoever's not allowed to come out stays inside. Oh, I'm sorry. This is a 3. So sorry to confuse. Thank you, Dylan. Good job. I have contacts in. I have such bad eyesight that I can't even wear glasses to drive in legally because I have such poor vision. My glasses are so thick you would laugh. I swear, they send them to space somewhere to get them as thin as they can, and still they come back really thick. But I have something in my left eye, and it's like making this eye really blurry, and I can't take it out because then I can't see it all. So I'm trying. I was trying to study something I'm doing in pre-calc, and I was putting it on my overhead, zooming in and reading it up here because I could not see it. So bear with me. Thank you for catching that. That y to the 3rd is this 3 right here. I wrote it 2 by accident. Thank you, Dylan. Okay, let's do another one. Cube root. Sometimes you get lucky and the number is a perfect cube or a perfect square. Like, you could still see like 9 under the here, and then there's no leftover, no remainder. Just like this, 27 is in our list, right? This is a perfect cube, and you're allowed to have negatives under a cube root. It just makes our answer negative. What's the cube root of negative 27 going to be?
9.
Negative 3. Remember where it is on your calculator if you need to find it. You go to math, and then, I can't see, is it 4? 4. And then negative 27, you should get negative 3. Did I? Yeah, I just can't see. Okay, math 4, JT. So there was no leftovers. That is a perfect square. If you're in these lists, you're not going to have something to circle like we did here. Now we just do our division. 3 goes into 6 how many times? 2. Any leftover? Nope, it goes in evenly. There's no remainder, right? 2 goes into 6 3 times with a remainder of 0. So there's no remainder to circle. But look, 3 goes into 14. How many times evenly? 4. 3 times 4 is the 12. So 3 goes into 14 4 times with a remainder of what? 2. And if you needed to go off to the side and do it, 3 goes into 14. You are right with the 4 there, Dylan. Remainder of 2. Okay? So how do I write my answer? Whatever's on top, this gets written. So that's negative 3a squared b to the 4th. Anything I circled goes stays, I should say, right there in the radical. You don't get to come outside unless you're a perfect square or a perfect cube, and that's what we're looking for when you do this. If you're not, you stay inside the radical. You don't get to come out and play. Okay? Let's do one more. This is a square root, right? When you don't see something, you know it's a 2. Is 80 in our list of perfect squares? No, close, but not exactly. So we have to figure out how to break 80 down. Using these numbers, find a number that goes into it. Sometimes you have more than one. Like 4 goes into 80. 4 times 20. But I know that I don't want to use that because 20 has 4 in it as well. So we would have to do the reduction twice. That means there must be a bigger number in this list that goes into 80. And sometimes I don't know either. Sometimes I just pick up my calculator and I start dividing 80 by different numbers. 80 divided by 9. Nope, can't be that. 80 divided by 16. There it is, 16 and 5. Okay, so the square root of 80, let's just use the space below it, is 16 times 5, right? So 80 is now 16 times 5. The reason we did that is because 16 is a perfect square. What's the square root of 16? 4. Goes on top because that's part of my answer. What am I going to do to the 5? Circle it. That's going to remind me in a minute because there's a lot going on. What goes on top is going to go out into the front in a minute. Whatever I circle gets stuck under the radical. 2 goes into 5 how many times? Evenly. 2 times. With how many left over? Circling it. It's going to be so easy in a second when I write my answer. Again, whatever's on top goes out to the front. Whatever I circled stays under the radical. And then 2 goes into 10 how many times? Any left over? Nope. So we don't have to circle anything for that one. Final answer, whatever's on top goes out to the front, right? That's these 3. And I can easily see, with all my stuff going on there, what goes inside is 5a. Okay. Good. So these take a little practice. I only gave you 6 problems. So please don't just copy my answers. Of course you can, and you're going to get 100 on your homework. But who cares if you're not going to pass a test or a quiz? Try them. Use my answers to check. And if you're not getting it right, all you have to do is ask me for help. I am happy. I say it every day. I mean it. I am happy to help you. As long as you're paying attention while I'm teaching and taking notes, you can ask me as many questions as you want. So I'm going to start out by just putting the, I don't know what I'm going to do. Page 351. So I wanted to have a way that you could just check your answers quickly. It's not easy to do it quickly. I don't know. And then I showed all the work on it. What do you guys want me to do? Which page? Should I show the work page? Is that better? Or, like, Kurt, if you want to take a picture of it, because I can't put the whole thing on here anyway. I can show up to 5. But if you want to just check your answer real quick, it's boxed, okay? But I showed all the work. You'll see some of my division over here, okay? So I can show 1 through 5 up here. Pretty big. Let me see if I can make this work. that's just the answers without the work, but I know it's hard to see anyway. So if anyone wants to come up here and take a picture with their phone of all of this so you have it in front of you, especially in the back, I am always okay with that. But I will put it on Canvas for